Welcome to Startup the Science, a podcast by ENAM, the Innovation Network for Advanced Materials. ENAM brings together companies, researchers, and investors working in the advanced materials space for the purposes of knowledge sharing and collaboration. We do this through our programs, events, and initiatives like the podcast you are listening to. In this podcast, we interview inspirational founders, experts, and investors and get a closer look at what they do. This is your host, Taha Adnan, and let's start up the science.
Mimotype is a developer and vendor of bio-inspired performance materials. The bioeconomy is about realigning production methods and supply chains with the vision of an ecologically seamless world economy. Our focus is on a peptide, i.e. a mini protein that acts as the luminescent agent for the light emission of marine life, a phenomenon known as bioluminescence. We extract the genetic blueprint of said target molecule and then have genetically programmed bacteria produce the substance for us. The material obtained in this way is to be used for OLED displays and adjacent applications. Mimotype will be able to deliver an accelerated lab-to-market timeline for bio-inspired emitter materials, reshaping the OLED market and other target markets in a capital-efficient manner from the bottom up.
This podcast was brought to you by Admacom sponsors SAIS Red Zone, the in-house open lab program from SAIS Getters. If you would like to get in touch, please reach out to the ENAM team. Welcome to Startup the Science. So glad you could be here today, Claudio.
Thank you for having me. It's a pleasure.
Yeah, and let's get straight into it. Could you tell us a bit more about your background, the stuff you've worked on so far, and yeah.
Certainly. So I have a background in molecular biology. I did a bachelor and master's degree at the University of Heidelberg in molecular biosciences. Mostly working in evolutionary science using genomics for decoding evolutionary patterns. And it was during my studies that I became interested in the phenomenon of bioluminescence, biological light emission, and generally also the emergence of complex evolutionary trait in a convergent, that is, independent and repeated manner. I started a PhD, but didn't really feel comfortable at the university anymore for various reasons. So I was really drawn to starting an entrepreneurial career, and nonetheless, my time in biology really deeply and profoundly shaped my thinking, not only in terms of the science that I'm interested in, but also just my outlook on life and also my entrepreneurial activities. Yeah.
At Mimotype, currently you are working with your brother?
That's right, yeah.
And how is it to be setting up a company with your brother? And what might it tell you about things you need in a co-founder?
Right, yeah, that's a very important question. Just right after I put my PhD on hold, my twin brother and I created a small innovation consultancy in Hamburg. We had a couple of projects in the area of biomimetics, nothing big though, but we did spun out our first company out of this activity. It was more in the domain of machine learning in the maritime industry, since we are both from Hamburg, and I moved from Heidelberg back to Hamburg. He has a background in law, and of course we are pretty similar since we are twins, but nonetheless he has a more, let's say, creative but also business-minded approach to how we do things at both our first company and Mimotype as well, while I really take care of the nuts and bolts of our biotechnology pipeline, and as far as I'm able also the physical prototyping of our OLED devices. So we'll get into our technology in a bit. I mean, we are really complementary in many regards. Of course, there's certain issues where we kind of differ, and sometimes it's hard to live together with your twin brother, because we also share the same apartment here in Berlin, but we work together and we live together as well. So there's a certain friction from time to time, but we really developed a toolkit to deal with these frictions and just make use of it and turn it into a productive discussion. that sometimes from the outside might sound a little bit harsh, but in reality it's just about finding the right way of doing things and finding common ground. And he's taking me out of my science bubble, and sometimes I'd stop him when he's going too far in speculating in a let's say somewhat creative way. So it's a really almost symbiotic way of working together, and it has brought us quite ahead so far in our careers. So it's just not imaginable to do things differently from here.
Okay, thank you for that. Very insightful. Yeah. Speaking of your experience with prior companies with your brother, you founded and successfully exited 4C.
Right.
And what was your experience with company exits, and what is some sort of advice that you could give to startups?
So in 4C, we were minority shareholders. My twin brother and I, we were more like technology managers, hiring the programmers that then built the deep learning engine. So this company was about creating a deep learning engine for market price prediction. Pretty cool stuff. But at some point we felt not really able to shape the vision of the company in a way that we set out to do. And this is when we decided to sell our share in the company. So that was the kind of exit that we had. We sold our share. There was a little bit of back and forth with the other shareholders in the company, to put it lightly. But we really went through the whole life cycle, from creating a company, hiring a team, building a product that worked. Back then it was a software product, now it's a hardware product. Also the human dynamics that come into play once you have senior staff with more junior staff, different cultures even clashing. So it was really stressful at certain moments, but again, I wouldn't miss this experience because it brought me to the point where I am now. And I don't think that I would have been able to create my own company from scratch, Mimotype, if I hadn't done the prior experience with our first startup.
So moving on to some of the research that you've done, you've worked on convergent evolution. So for our listeners, some of whom might not know what convergent evolution is, could you provide a brief description?
Sure. So convergence really is something dear to my heart. Just think about all the different creatures in nature that emit light. So there are fireflies, there are crustaceans in the ocean, there's even squid that have their own biological light emission going on. And obviously, these organisms are really distantly related. And just by the fact that these organisms are so distantly related, you already know, or you can already see that the evolution of the bioluminescence happened independently and repeatedly. And in the case of bioluminescence, it happened, as far as we know, more than 40, 50, even 60 times independently. So you have all of these molecular systems that are somewhat different to each other, but they have the same function. So this is really how I look at convergence. So you have a function that is of interest, and then you have different molecular systems, let's call it, that can implement these functions. So this is a kind of systems level view on what convergent evolution is. And then there are other well-known examples, like the evolution of the eye is convergent. Even nervous systems emerge convergently. So it's just fascinating to consider the fact that these highly complex evolutionary traits came together again and again, not only on a morphological level, but down to single molecules even.
And what do you think that tells us about the complexity of life in terms of, especially extrapolating to astrobiology and looking for life on other planets?
Oh, cool. Yeah. Thanks for diving into this. So, I mean, you could really go all philosophical here and talk about the very fabric of nature and reality, but I won't go so far. Just let me put it this way. So there are different schools in evolutionary biology. And essentially it boils down to the convergence versus contingency debate. So there's one school that says, okay, it's all random, and essentially life on other planets would look differently. But then the convergence guys say, okay, there are these deep systemic structures to the way that life is actually organized and emerges. And this is why life on Europa, for example, so the moon of Jupiter, so life would be pretty similar. Thinking about the fact that it might also originate at hydrothermal vents down somewhere in the abyssal ocean of Europa. It might even be bioluminescence. So there was something that I worked upon in my bachelor and master thesis, and actually also presented at a couple of high-level conferences. Just this hypothesis that when there's life on Europa, that it will have one trait, it's going to be probably bioluminescent, and this would also be a way for a robotic probe to actually detect signatures of life on Europa. So this is my take on convergence. I'm more really going in the direction of these deep systemic constraints that life has for some reason, and it's fascinating to explore these constraints and see how living systems come together.
That sounds very, very interesting. For me personally, I think it's a bit more hopeful to think about finding alien life and then finding similarities with alien life. If it's something out of the ordinary that we don't normally see, that is amazing. But if it's something that's very similar as well, I think in a different type of way, it's just as cool. So moving on to Mimotype in general. So how did you come up with the idea of Mimotype? I'm sure it has to do with your work in convergent evolution and bioluminescence. But was there an aha sort of moment where you realized, oh, I can make this to a product that can be a startup?
That happened 2 or 3 years ago. I was just brainstorming with a friend, and we were actually thinking about a business case in vertical farming. And from vertical farming, we then looked at OLED. And this is when I started just to really familiarize myself with OLED. I had heard about it before, but I wanted to know more. And I just saw this similarity between the kind of light that that OLED emits with the type of light that I studied in my evolutionary studies. So just the light quality was somewhat similar. And this is when I started to then really dive deep into the molecular structures of these light-emitting molecules. And I saw similarities to the molecules that I had been studying using genomics and using DNA sequencing. And I had been following this the whole biomanufacturing paradigm, looking at major US companies that have been doing really ambitious biosynthetic projects for years. And then I had the idea, okay, so which pathways are known, which molecules can be produced, and if we can produce them using a microbial host, can we then take these molecules out of the bioreactor and put them into OLEDs? And it was all a pretty far-fetched, crazy idea, but I then applied to an accelerator program here in Berlin, Reactor Berlin back then, and I got in, although I didn't have anything to show at that point. And I just further sketched out all of the theoretical aspects and then initiated contact with Professor Liz Kratovil here at the Humboldt University, ordered the first 200 milligrams of a chemically produced analog of the material that I'm interested in. So that was already pretty expensive, but I didn't have the resources to ramp up a biosynthesis campaign. Yeah, and it worked. So it took 6 months to produce the first lab-scale OLED. But from there, then it was really clear that also looking at some other publications and research programs that had been done in this area, it became clear to me that you can really put a dedicated effort on using bio-inspired molecular structures and put them into OLED.
Mm-hmm. Yeah, so what would be the advantages of making or of sourcing our materials in a reactor, let's say, rather than just from a chemical synthesis point of view?
Yeah. So the current generation of OLED emitters contains scarce and toxic heavy metals, rare earths. This is just a matter of price. So OLED emitters are really expensive. 1 gram is between 1,000 to 5,000 euros. It's also complicated to synthesize these emitters in a multi-step organic synthesis reaction. So you have losses along the way during each synthesis step. And you also use lots of water and heat for this chemical process in the chemical factory. And toxic solvents, so not good. And the idea now is to substitute chemical factories with bio manufacturing plants, bioreactors, fermenters, where you have the batch-wise production, let's say in the kilogram range of these emitter molecules that we are interested in.
Okay.
And solving all of these issues that I just mentioned.
Yeah, just to dwell on Mimotype's technology a bit more, what is the roadmap for the company in terms of when do you foresee production, and what does success for you look like? At what point would you consider Mimotype to be a successful startup?
So I already consider it a successful startup. So we made it up from the ground. So that's already the biggest milestone. But for us it's easy. So either we can observe light emission or not, and this is really where we put our molecules to the test. The idea is to ramp up the bio pipeline. So we are already producing our target molecules in the milligram range. This is not enough, so we need to scale up to 100 gram yields within the next 12 to 18 months. To then start selling 100 milligram test batches to select test customers. Biology is messy. We have encountered a couple of problems along the way. The purification of the peptides out of the protein scaffold, that's difficult. Also the minute amounts that we produce. So it's hard to work with this and then use these samples in the OLED prototyping. So we have to really develop these R&D tracks in parallel. On the one side, the OLED prototyping, and on the other side, the biosynthesis scheme. And within the next 12 months, they are going to merge, and then we have enough material to actually put bio-derived emitters into our OLED stacks.
I see. What do you think the future of bio-inspired electronics is? What do you think the future holds?
Okay, so I definitely think that organic electronics is going to shape the way that we experience the world in the future. For various reasons, various products. I mean, we are already interacting with screens a lot, so we have to optimize that. With flexible printed electronics, so just merge these displays into our environment, so that we really have a superior way of working in the digital realm than we do now, and it's going to be, or these types of technologies are going to be everywhere in automotive, aerospace, medicine technology. So we are especially interested in wearable technology and also looking at a couple of textile use cases, ambient lighting as well. So light is has been a human technology, a factor shaping civilization for thousands of years. So this is why we really need new materials that are ecologically seamless to maintain a healthy relationship with the electronics that we are going to use within the next 50 years, 100 years.
I see. Do you have any advice for startup founders, especially when you're working on a groundbreaking technology such as yours? I'm sure you must face a lot of opposition to your ideas at times. Do you have a personal philosophy to share with us that might help other startup founders also get through times like these?
So I will tie it back to what I mentioned in the very beginning, this really interesting phenomenon of convergent evolution. So if you have a technology solution that involves convergence in some way, shape, or form, for example, you have multiple ways of coming up with a solution, then that's a good thing. So that's a good thing for us because we can try a lot of different molecular systems. One doesn't work, another one works. And we know that we have this huge variety of different systems to choose from. And this is why I was convinced from the very beginning that we can go through with this. Mm-hmm. So I saw this attractor in the hyperspace of technological complexity, so to speak, and I never lost sight of it. And when a founder is actually really convinced that he has identified a technological attractor, then he should do everything to get closer to this attractor and not lose sight of it. And at one point, the technology attractor is kind of creating a force field where then stuff just happens. With us, for example, so we have some really interesting new collaborations going on, and people are just fascinated by the idea of biological light and using these molecules for an industrial scale use case. But you're also right, then when we actually enter into negotiations and talking money with investors, then it's all too experimental, and the current performance is not really comparable with the highly performant emitters that have been around for 20 years. Yeah, so you need to be really convinced and adamant about your use case, about your vision. And for me, it's really this almost Promethean vision of blue light. It's just magic, and there are so many systems in nature that can actually produce blue light. So this is why, just following this signal was the right way, and we did so. And we got our first pre-seed financing round in November, and we're topping that up right now. And now it's just fascinating to see how the company develops, how our staff scientists are working in the lab, creating OLEDs, how the bio experiments are coming together. As I said, things are converging, and I'm really happy and grateful for the state of things right now.
Mm-hmm. Well, thank you so much for your time, Claudio. We at Enam really wish you the best of luck in your future endeavors, and hope to be working with Mimotype in the future as well.
Thank you. So Enam is a great organization. You guys have helped us out a lot, and keep up the good work.
Thank you so much.